Good evening. In today's session, I am going to continue with the problems given in previous JEE main exams based on the topic Newton's laws of motion and conservation of momentum. So, let us start the problems. Look here, read the problem. A particle of mass m originally at rest is subjected to a force whose direction is constant but magnitude varies with time as that equation. Where F0 and T are constants, force acts on it for the interval of time 2t, the velocity of the particle after time 2t. So, here I am writing the data given. Mass of the particle is given as m, its initial velocity is 0, a force acts on it for time 2t, what is the final velocity? If the force is a variable function of time, then impulse or change in momentum m into v minus u is integral f dt. So, here u is equal to 0, m is capital M into v, that is integral force is given like this, F naught into 1 minus T minus T by capital T whole square into dt, limits are from 0 to 2t. So, F naught we can take it outside. So, 1 minus I am expanding this, t square plus t square minus 2t into t by t square dt, right. So, this is F naught into t square, I am taking t square as the LCM. So, t square minus t square plus 2t into t dt. So, here t square and t square gets cancelled. This can also be taken outside the integral because this is a constant factor. So, m into v is equal to F naught by t square integral 2tt minus t square, 2t minus t square dt. So, this is F naught by t square, integral t is t square by 2. So, 2 into t square by 2 into t, integral t square is t cube by 3. So, t cube by 3. So, this is F naught by t square. See, you have to substitute the limit, upper limit, that is 2t in place of small t. So, this becomes 2t whole square, 4t square into t minus t cube, 2t whole cube, 8t cube by 3, right. So, t square into t is t cube, you can take the t cube as a common factor outside, this becomes F naught, look here, this is F naught by t square. If you take that t cube as a common factor, 4 minus 8 by 3. This is F naught into t, if you take LCM 12 minus 8. So, this is m into v, left hand side here is m into v. So, mv is equal to F naught t into 12 minus 8, 4 by 3. You are supposed to find the velocity at the end of the force. So, v is equal to 4 by 3 F naught t by m. That is the answer. 4 by 3 F naught T by M. So here the main concept is, in case of variable force, impulse is integral f dt, right? Impulse is m into v minus u. Just we have integrated the given force with respect to time, and on substituting the limit, because if you substitute the lower limit, you just get it as 0. So we have just substituted the upper limit. Okay? Now look into the next problem. A spaceship in space sweeps a stationary interplanetary dust. As a result, its mass increases at a rate dm by dt is equal to bv square, where velocity is instantaneous velocity. What is the instantaneous acceleration? Here, rate of increase of mass is changing with time, and velocity is also, mass is increasing with time, velocity is also increasing with time. So here it's a very interesting problem. Look here, the spaceship in space, actually that is the key word in the problem, sweeps such that its mass increases at a rate, where v is instantaneous velocity. What is the instantaneous acceleration? So here force is equal to rate of change of momentum, right? Implies F is equal to d by dt of m into v. Here if m is constant, we just write it as m into dv by dt. Here m is also changing with time, velocity is also changing with time. So on partial differentiation, F is equal to dm by dt into v plus m into dv by dt. Okay, see here the most important word, as I said, is in space. So the external force acting on the system is 0. So this force is equal to 0. If that is equal to 0, what happens? dm by dt, or this one, if you bring this to this side, m dv by dt is acceleration. M into a is equal to minus dm by dt into v, minus dm by dt into v. Now look here, m, what is m? The mass, let us take it as capital M, into a is equal to minus dm by dt is given as b v square into v, into v. So it is done. ma is equal to minus b v cube. So acceleration is minus b v cube by m. This is the answer for that problem, minus b v cube by m, where m is a function of time. So here the hint is force is the rate of change of momentum. Mass is also a variable function of time here. So you have to apply partial differentiation, and then we have taken the condition the external force is 0 because the spaceship in space, the external force acting on the spaceship is equal to 0. Okay? Now let us move on to the next problem. A ball is thrown vertically up, taken as positive z axis from the ground. The correct momentum height diagram is, when a ball is projected vertically up, its velocity, hence its momentum, decreases as height increases. It reaches the maximum and then it comes back to the ground. So actually when it is falling down, v square is equal to 2gh, or v or momentum is proportional to root h. So, while going up, it decreases as height increases, while moving down, it increases, momentum increases as height decreases. So, here what is our inference? As it moves up, height increases, momentum decreases. Then momentum becomes equal to 0. Momentum becomes equal to 0, then height decreases and momentum increases in the opposite direction. See here that this is not correct because relation between momentum and height is not a linear relation. So, this is not correct. And coming to this, here this is very obviously initially momentum is maximum. So, it decreases as height increases, becomes 0, then as it falls down, height decreases, momentum increases, but in the opposite direction. So, this is the perfect graph, right. So, in case of a vertically projected body, another question given in another exam is, what is the relation between height and velocity? Exactly the same, because momentum is the product of mass and velocity. Okay? Now, let us move on to the next problem. Look here, a man of 60 kg is running on the road and suddenly jumps into a trolley of mass 120 kg. Then the trolley starts moving with the velocity 2 meter per second, velocity of the running man. See here, this is a trolley of mass 120 kg which is initially at rest. A man of mass 60 kg jumps onto the trolley with some velocity. So, after that, the man is in the trolley, both of them they started moving with a velocity 2 meter per second. So, here this is based on law of conservation of momentum. There is no external force acting on the system. So, the total momentum of the system before is 60 into u, its velocity is 0, trolley velocity. So, it has no momentum before. When he jumps into the trolley, this is 120, this is 60 kg, together 180 m into common velocity. So, m1 u1 plus m2 u2 is equal to m1 plus m2 into v. As u2 is 0, simply we have taken this. So, from this u is equal to 180 into 2 divided by 60, that is 6 meter per second. So, it is a numerical question, answer is 6 meters per second. Okay? Now, let us go to the next problem. A batsman hits back a ball of mass 0.4 kg straight in the direction of the bowler without changing its initial speed 50 meter per second. See here, this is the location of the batsman and this is the position of the bowler. So, this a ball strikes the batsman with a velocity 15 meter per second and it is reflected back exactly in the same line towards the bowler with the same speed. So, here velocity with which the ball strikes the bat is v, velocity with which it is reflected back is v. So, here impulse is nothing but change in momentum, m into v minus of minus v, because the direction is reversed here. So, mass is 0.4, velocity is 15 plus 15, it is 0.4 into 30. So, impulse is 12 Newton second is the correct answer for that problem. It is 12. right? Let us move on to the next problem. They are so easy, isn't it? Now, a projectile motion particle of mass 5 grams is as shown in the figure. Initial velocity of the particle is 5 root 2. Air resistance is negligible. Magnitude of change in momentum between A and B is x into 10 power minus 2. See here, let this be a projectile. So, it is projected with a velocity u at an angle theta with the horizontal. What is the horizontal component of initial velocity? U cos theta. Vertical component of initial velocity is u sin theta. When air resistance is ignored, there is no loss of Ke, so it reaches the ground with the same speed at the same angle. Then its component along the horizontal is u cos theta, along the vertical is u sin theta. Here there is an interesting thing. Along the horizontal, there is no change in velocity because acceleration component is 0. Along the vertical, initially it is up, finally it is down. So, change in velocity is 2u sin theta in the vertically downward direction. You are asked to find change in momentum. So, change in momentum on reaching the point B from the point A is equal to 2 mv or 2 mu sin theta. So, here 2 mass is given as 5 grams. If you want to convert gram to kg, 10 power minus 3. And velocity. What is velocity given? 5 root 2. Here velocity is given as 5 root 2 and theta is given as 45 degrees. So, sin 45. This is 2 5s are 10, 50. It is 50 root 2 into 10 to the power of minus 3. Sin 45 is 1 by root 2. This and this gets cancelled. It is 50 into 10 to the power of minus 3 kg meter per second. But here it is given as x into 10 to the power of minus 2. So, this becomes 5 into 10 to the power of minus 2 kg meter per second. So, x into 10 power minus 2, in place of x we have 5. That is the answer. Is it all right? So, here in case of a projectile, change in momentum on reaching the ground or on returning the ground is 2 mu sin theta. If the body is projected from the ground, on reaching the ground, its change in momentum is 2 mu sin theta. So, this is the answer for that problem. Now, look into the next problem. A bullet of mass 0.1 kg is fired on a wooden block and pierces through it, but it stops after moving a distance 50 centimeters. Velocity of the bullet before striking the wooden block is 10 meter per second and it decelerates with uniform deceleration. Magnitude of effective retarding force is given as x Newton. You are supposed to find the value of x here. So, a bullet is fired with a velocity u is equal to 10 meter per second. It stops after moving a distance 50 centimeters. So, here final velocity is 0 after travelling through a distance. Final velocity is 0 after travelling through a distance 50 centimeters in that wooden block. If you convert that 50 centimeters to meters, it is 0.5 meters. What is asked here? You are supposed to find the force. We know force is equal to m into A. Mass of the bullet is given as 0.1 kg. If you know acceleration, you can find out force. So, find out acceleration. What equation connects them? V square minus u square is equal to 2as. So, minus 10 square is equal to 2a, s is 0.5 meters. 2.5s are 1, a is equal to minus 100. So, substituting this value of a in this, magnitude of effective retarding force, we are just supposed to find the magnitude, that is m into a, 0.1 into 100, this is 10 Newton. So, the answer for that is 10 Newton. Is it all right? Let us move on to the next problem. A body of mass m is suspended by two strings making angles theta 1, theta 2 with the horizontal. Let us draw the diagram. This is the horizontal. A body of mass m is suspended by two strings. These are the two strings by means of which a body of mass m is suspended, and they make angles theta 1 and theta 2 with the horizontal, and the tensions in the strings are given as T1 and T2. So, you are supposed to, the relation between T1 and T2 is given as T1 is equal to root 3 T2. You are supposed to find theta 1, theta 2 and T2. Three things are to be found. Here, let us apply Lami's theorem. You know, this is Lami's theorem. Let this be P, let this be the force Q bar, this is P, this is R. Angle opposite to P is alpha, angle opposite to Q is beta, angle opposite to R is gamma. Then Lami's theorem states that P by sin alpha is equal to Q by sin of its opposite angle is equal to R by sin gamma. This is a Lami's theorem derived from triangle law of vectors. When three concurrent forces, that means forces simultaneously acting on a point, keep that point in equilibrium, then from this diagram P by sin of opposite angle, Q by sin of opposite angle, R by sin of opposite angle. Now, we are going to apply Lami's theorem to this problem. Just if you apply that, here this is where if mass is m, weight becomes mg, right? This is theta 1. So, this angle becomes alternate angle theta 1. The total angle becomes 90 plus theta 1. Similarly, if this is theta 2, the total angle becomes 90 plus theta 2. Now, from Lami's theorem, T1 by sin of its opposite angle, that is sin 90 plus theta 2 is equal to T2 by sin of its opposite angle, sin of 90 plus theta 1. Look here, it is given T1 is equal to root 3 T2. Because you need to find out T2, let us replace T1. Root 3 T2 by sin 90 plus theta 2 is cos theta 2. This is T2 by cos theta 1. So, T2 and T2 gets cancelled. Cos theta 1 by cos theta 2, cos theta 1 by cos theta 2 is equal to, if you take this, this comes here 1 by root 3. Cos theta 1 by cos theta 2 is equal to 1 by root 3. See here, let us check the possibilities. See, theta 1 is equal to 60 degrees and theta 2 is equal to 30 degrees. Okay, you can actually guess that. Here, it cannot be 45. So, theta 1 is 60. If theta 1 is 60, cos 60 by cos 30 is equal to 1 by 2, root 3 by 2. So, cos theta 1 by theta 2 is equal to 1 by root 3. So, this is, theta 1 is 60, theta 2 is 30. So, answer is found, because with those theta 1, theta 2 values, there is only one option. But let us try to find out T2 also. From this Lami's theorem, look here. From this diagram, see, I am redrawing the same thing. See, this is weight mg, this is theta 1. Theta 1 is 60 degrees now, and this is 30 degrees now. This is T1, this is T2. What will be this angle? So, in this triangle, total angle is 180 degrees. So, if this is 90, this sum of these two is 90, this will be 90. So, here from this mg by sin 90 is equal to T2 by sin of 90 plus 60. Sin 90 plus 60 is cos 60. Sin 90 is 1. So, T2 is equal to mg cos 60. Cos 60 is 1 by 2. So, T2 is equal to mg by 2. T2 is equal to mg by 2. That is purely based on Lami's theorem. Okay? Now, move on to the next. A body of weight 200 Newton is suspended from a tree branch through a chain of mass. Let this be a tree branch. This is a chain of mass 10 kg from which a body of mass 200 Newton is suspended. Branch pulls the chain by a force. So, actually the tension in the rope will be the force with which the branch is pulling the rope. So, here this at this point tension will be 10 into G plus 200, because from this point the total weight is action reaction here. The total weight suspended from the tree is 10 into 10, 100 plus 200, it is 300 Newton. So, the weight pulls the branch with a force 300 Newton. In turn, the branch pulls the load with the same force, that is 300 Newton. That is too simple, isn't it? Yes? Now, move on to this. A cricket player catches a ball of mass 120 gram moving with a velocity 25 meter per second. If the catching process is completed in 1 second, in 0.1 second, magnitude of force exerted by the ball on the hand of the player. So, very obviously F is equal to ma, right? Here mass is given in grams, it has to be converted into kg. 1 gram is 10 to the power of minus 3 kg. And here initial velocity is 25 meter per second. Initial velocity is 25 meter per second. Final velocity is 0. Time of action is 0.1 second. So, acceleration is, or directly we can write F is equal to m into v minus u by t. So, this is 120 into 10 power minus 3. Actually, you get a negative sign because v is 0 minus u, but just force exerted by the ball on the hand of the player. On the force exerted, look here, suppose this is the hand, this is the ball. Force exerted by the ball on the hand will be in this direction, on the ball will be in the opposite direction. So, that opposite sign is included in the question. So, simply we are supposed to find the magnitude of the force here. It is 120 into 10 power minus 3, velocity is 25 divided by time is 0.1. So, here it is 10 power minus 2, 10 power minus 1, 12 25s are 300, right? 300 into 10 to the power of minus 1, it is 30. So, the force exerted, the magnitude of the force exerted by the ball on the hand is 30, magnitude of the force exerted by the hand on the ball is also 30, but as they form action reaction pair, they are equal in magnitude, opposite in direction, right? Now, go to this problem. As shown in the figure, a 70 kg garden roller is pushed with a force of 200 Newton at an angle 30 degrees, normal reaction. Look here, this is the roller, its weight mg will be acting in this direction. This is the pushing force applied. Pushing force is given as 200 Newton. It makes an angle, this pushing force is making an angle 30 degrees. So, here angle made by this with this is 30 degrees. So, the component of this along this direction becomes 200 sin 30 degrees. So, the force with which the roller presses the ground is mg. M is given as 70, g is given as 10 plus 200 sin 30. This is the force exerted by the roller on the ground. So, the normal reaction or reaction exerted by the ground on the roller is the same thing. So, this is 700 sin 30 is 1 by 2. This is 700 plus 100, it is 800 Newton. This is the correct answer for that problem. Okay. Now, move on to the next problem. Okay. See here, a block of mass m is placed inside a box, descends vertically with an acceleration. This is a box, let us, and a box of mass m is placed inside this big box, and this big box is moving, descends with an acceleration a. The block exerts a force equal to 1/4 the weight on the floor, the value of A. See, look here, actually its weight will be acting in the downward direction, and the pseudo force on this will be acting in the upward direction, that is MA. The apparent weight of this block inside this big box is m into g minus a. So, apparent weight is nothing but this is the force exerted by this block on the floor of the big box in which it is placed. Okay. It is just similar to the case of the normal reaction on a block placed in a lift accelerating down. When the lift is accelerating down, apparent weight is m into g minus a. When it is accelerating up, apparent weight is m into g plus a. So, exactly in the same way, see here, this is accelerating down. So, pseudo force is in the upward direction, mg is in the downward direction. So, apparent weight or the force exerted by the block on the floor of this big box is m into g minus a. It is given as 1/4 of its weight. Weight is mg, 1/4 of its weight. So, here 4g minus 4a is equal to g. So, if you take this to the other side, 4a is equal to 3g or a is equal to 3g by 4. So, the acceleration with which this is moving down is 3g by 4. Okay? Now, actually, if you are smart enough, you can directly tell the answer, isn't it? Its weight is reduced to 1/4. So, reduced by 3/4. So, g is effective acceleration is reduced by 3/4. So, 3 by 4 g is the acceleration of the lift in the downward direction. Now, look here. In this arrangement shown in the figure, A1, A2, A3, A4 are the accelerations of masses M1, M2, M3 and M4. Right? Which of the following is true? Here, the thing we are taking is sigma of T A is equal to 0 from the concept of work done, isn't it? So, sigma of T A. Suppose here, if this is tension T, this becomes 2T, this becomes 2T, 2T plus 2T, this becomes 4T, this becomes 4T. So, from that 4T A1 plus 2T A2 plus T A3 plus T A4 is equal to 0. If you take the T as a common factor outside, 4A1 plus 2A2 plus A3 plus A4 is equal to 0. Search for this option. So, 4A1, this one. 4A1 plus 2A2 plus A3 plus A4. This is the most important hint for that problem. We have done several problems based on that hint. Now, again, another problem based on Lami's theorem. Look here. See, a body of mass 1 kg is suspended with the help of two strings making angles as shown in the figure. Tensions are T1 and T2 respectively. So, you have to find out the tensions. Look here, mass is 1 kg, mg is 10 Newton. So, I am just drawing that figure. See here, like this. This is T2, this is T1, this angle is 60 degrees and this angle is 30 degrees. Again, this angle will be 90 degrees. And the force suspended is, the weight suspended is 10 Newton. Mass is 1 kg, g is 10. So, it is 10 Newton. From Lami's theorem, 10 by sine of its opposite angle is equal to T1 by sine of its opposite angle. This total angle becomes 90 plus 30. So, sine 90 plus 30, everything is in degrees. That is equal to T2 by sine of its opposite angle is 90 plus 60. Sine of 90 plus 60. So first let us try to find out T1. T1 by cos 30 is equal to 10. T1 is 10 into cos 30. Cos 30 is root 3 by 2. It is 5 root 3. So T1 is 5 root 3. And coming to T2 from this. T2 by cos 60 is equal to 10. T2 is 10 cos 60. 10 into 1 by 2, 5. So T1 is 5 root 3 and T2 is 5. Just a simple application of Lami's theorem. So let us go to this. A square lamina is pivoted at the point O. Forces act on the lamina as shown. Lamina remains stationary, then the magnitude of the force. See here, actually we apply, so if this is stationary, sum of the clockwise moments must be equal to sum of the anti-clockwise moments. Now just look here, this about this point has no torque because it is acting along the same line. This about this point, okay, this produces torque in this direction, whereas this produces equal and opposite torque cancel. These two torques cancel each other. This is acting along the same line. This doesn't create any torque. Then this 10 Newton produces in this clockwise direction. This force about this point produces torque in this direction. So these two should balance each other. So torque of the force about O is force into this perpendicular distance, because it is a square lamina of length 10 centimeters, FL. That is equal to force, and this is the perpendicular distance L. This and this gets cancelled. F is equal to 10 Newton. The problem is so simple. Okay, so I'll stop here for today. I'll continue in tomorrow's class with some more problems. Thank you and bye-bye. Okay.